Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for jump game problem. Let's look at the problem description. We are given an integer array nums and we are positioned at the first index, and each element in the array represents the maximum jump length, and we have to return whether we can reach the last index. If we can reach, then we have to return true, otherwise we have to return false. Let's take a look at this example 1. We have the input array 2, 3, 1, 1, 4, meaning when we are at index 0, we can jump 2 positions. When we are at index 1, we can jump 3 positions. And when we are at index 2, we can jump only 1. When we are at index 3, we can jump only 1. So in this case, from initially we are positioned here, and either we can jump here or there in the second index. So when we jump to the first index, we have the jump length, maximum jump length is 3. So we can maximum jump 3. So in this case we can reach the last elements. So that's why we return true. 0 to 1, 1 to the last index. So the length of the array is 10,000 and the value is ranging from 0 to 100,000. Let's look at the approach to solve this problem. We have this input array and the expected output is true. There are two approaches. One is the brute force, which is the exhaustive search. So in this case, we come up with all possible path to the last index based on the jump length. Okay. So for example, let's take a look at the tree representation of that. Okay, so initially we started at index 0. Okay, from there we can jump two positions. One is index 1 and the second one is index 2. So when we go to index 1, we can jump the next 3 locations. So from index 1 to, we can jump either index 2, index 3 or index 4. When we reach index 2, we can jump only 1. So we can jump to 3. And from 3, again we can jump only one position. So we can reach 4. This is one path. And from the index 1, either we can jump 2 positions at a time. We ended up index 3. From there we can jump only 1. We can reach the last index. And from index 1, we can jump 3 steps at a time. So eventually we land in the last index. So, and then in the case of from 0, we can jump 2 positions at a time. So we landed in the index 2. From there we can jump only 1 position. From there jump only 1 position. We reach the last index. Okay, there are multiple ways we can reach the last index. And so once we reach here in the recursive procedure, we can mark this last index is reachable, whichever the path is hitting first. Okay, so but this complexity of this approach is exponential. It depends on the branching factor at each node. In this case, it's the jump length of that given index. As per the problem statements, it's 100,000. So the jump length value is 100,000. It will be 100,000 to the power n. Okay, so which is inefficient. Let's take a look at the second approach, in which we traverse the input array linearly. And so in this case, at each index we visited, we compute what is the maximum length we can jump from that index. And also at any point, if we have a negative jump length, that means we cannot move further. We are stuck. So In that case, we can return false, saying that the last node is not reachable. In this case, the time complexity is the order of n. Here, the space complexity is the order of 1. Here, the space complexity is the height of this tree. Let's look at the flowchart. Input for this procedure is the nums array. First, we initialize the max jump length and then return value and then the count variable. Max jump length is initialized to 0. Count will be the size of the input array and then the ret value. So it's basically a typical for loop. First we check whether all the elements are processed. If so, we come out of the loop and return the current value of the ret val variable. Otherwise we enter and we check whether the max jump length is less than 0. If so, we cannot move forward from that current index. So we set the return value to false and return. Otherwise we check whether the current jump length of that index we are visiting right now is greater than the max jump length that we are tracking. If yes, we assign the current jump length to the max jump length variable. Otherwise we skip that, and then after visiting each index we have to decrement the current value of the max jump length variable. Okay, and then we increment the index until all the elements are processed. Finally we return the ret val. Let's move on to coding. First I initialize the max jump length variable to 0 and then the ret val variable to true. Then I enter the for loop which traverses the input array. So for each index, value is assigned to the current jump length variable. That indicates from that index how far we can jump. So first thing inside the loop we do is check the max jump length is less than 0 or not. That indicates the condition where we cannot reach the last index or move forward from that index. Okay, so we set the return value to false and break out of the loop. Otherwise we check whether the current jump length is greater than the max jump length computed so far. Then we updated the max jump length to the value of the current jump length variable. After that, in order to mark that we jumped one step, we reduce the max jump length by 1. Then after traversing all the input elements in that array, then we return the ret val back to the caller. Next I am going to run the test cases. Okay, all the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. Okay, let's do the code walkthrough with this input. We initialize the max jump length to 0 and then the ret val to true. We start with the index 0, so the current jump length with respect to that index 0 is 2. Okay, on each iteration we get the current maximum jump that current index can do. Okay, so on iteration 0 the max jump length is 0 when we enter the loop, and the current jump length will be 2. Okay, so first we check whether that max jump length is less than 0. It's not, it is equal to 0. So next we check whether the current jump length is greater than the maximum jump length. Yes, it is. So what we do, we assign the current jump length, which is 2, to the max jump length. Then we decrement the max jump length by 1. So the max jump length will be 1 at the end of the iteration 0. On the next iteration, the index points to 3. We can jump maximum 3. So when we enter the loop, the max jump length is 1 and the current jump length is 3. So since max jump length is greater than 0, we will not hit this condition. Then we check the current jump length is greater than max jump length, which is true. So we assign the current jump length 3 to the max jump length. And then after that if block, we decrement the max jump length. So we get max jump length as 2. On iteration 2, we have the current jump length is 1. When we check the max jump less than 0, that is also false. And the current jump length is also less than the max jump length. So this is also false. So we come out and we decrement the maximum jump length. So it will be 1. At the iteration 3, we point to index 3 where the maximum jump length is 1 and which is equal to the max jump length. So we are not updating it. But after we come out, we decrement the max jump length. So we get 0. Okay. On the iteration 4, we are now at the last element and we check the max jump length is less than 0. It's false. So we check whether the current jump length is greater than the max jump length. Yes, it is. So we update the max jump length with the current jump length, which is 4. And then we decrement that value by 1. So eventually we have the max jump length as 3. And then the ret val so far is not modified. And also we reach the end of the array. So we come out of the loop and then we return the return value, which is true. That is an expected output for this input. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. So here we have totally 5 elements. And let's see how many times this for loop runs for this size of the input. So it basically traverses all the elements in that input array. So in this case, it is running 5 times. Okay. Time complexity of this algorithm is order of n. And the space complexity is order of 1 because we do not allocate any additional space with respect to the size of the input. So we have just 2 variables declared. So the space complexity is order of 1. Thanks for watching this video. Have a great day.